Alright, here we are. We're going to do one more example of U substitution, only this time we're going to do one involving trig functions. And so we've got this integral of cosecant squared times cotangent to the sixth over 7 dx. And first and foremost, just kind of throw an extra step in there. This fraction can get pulled out in front. Whoop. So we're left with cosecant squared times cotangent. And because we have multiple functions, and in particular we have a product of two functions, we want to ask ourselves, are those two functions related? And as it turns out, they are. We know that the derivative with respect to x of cotangent is cosecant squared, negative cosecant squared. And so when you have this relationship where one function is related to the other with a derivative, it makes it a great candidate for U substitution. And so if we set U equal to cotangent, then we can make du, the derivative of U with respect to x, equal to negative cosecant squared x. And then if I isolate my du, I can write it like this. And if I look back at the original, what we have here is we have our dx and our cosecant, and that's in here. And you can think about this negative as a constant. If you want to think about it as -1, you can. If it helps even more, we can move it over here to completely isolate what shows up in our integrand. And we now are ready to make our substitution. Just so it's absolutely clear, let me rewrite this one extra time and show you that I can write this as cotangent to the sixth, cosecant squared x dx. And now I'm ready to exchange this with a negative du, and my u, where'd my u go? My u's up here, is cotangent x. So cotangent to the sixth, I can think of this as u to the sixth. And so I now have this integral where I can rewrite it as -1/7 u to the sixth du. Because this is a constant, this -1, I moved out here in front with the 1/7. And again, similar with the last example, I've taken a relatively complicated integral that we started with and turned it into a power function. So if I take the antiderivative, I've got u to the 7th, 1/7. And I've got this -1/7. That's along for the ride. And then, of course, my plus c. So what I have is -1 over 49, u to the 7th plus c. And the very last step is to take my u, which was cotangent x, bring it back down here, and plug it back in. And that's the antiderivative. Again, you could also write it as the cotangent with the 7 here. And we're good to go. Thanks for watching.